persistence mechanisms, an attacker's best friend. Not only can they get in and do whatever they want, but you try and kick them out, they have a backdoor right back in. So today we're going to talk about a real-world use case of persistence mechanisms, and in particular Chrome extensions, and how oftentimes attackers can bypass traditional detection techniques by hiding within the actual application of Chrome itself and the process of Chrome itself by loading extensions directly into Chrome. However, it cannot hide from AI query. Let's show you exactly how. Alright, so before we hop into the tech, let's start here within MITRE in the attack framework. If you're not familiar, as we mentioned kind of in the last video, so MITRE attack framework, wildly helpful. Basically, it is a ever-evolving knowledge base of the tactics, techniques, and procedures utilized by adversaries, making it wildly helpful for us as defenders to be able to identify the techniques utilized in trying to exploit environments. So in this case in particular, we're going to be focusing in on the persistence tactic with the sub-technique of T1176, which, as you can see over here, software extensions, and specifically 001 browser extensions. Again, there's a bunch of these we could talk about. Some of my other videos I talk about registry-based persistence, but in this video, we're going to focus on browser extensions in particular, and I'm going to have a specific focus on Chrome extensions, and the reason for that is because of real-world scenario. So this actual real-world practical scenario, I was brought in, I was helping out a little bit with a IR engagement, and they had this issue where they had this beaconing out to a C2 server, and they couldn't figure out where exactly it was coming from or why it kept persisting after multiple times of reimaging the machine. Well, what they found, which I didn't know necessarily at the time, but just happened when I bought my new computer, which made me think about it, is that your Chrome profile is going to load the browser extensions if you have sync on by default, which is on by default. So every time they wipe the user's machine, everything was clear. They install Chrome, sign in, and then the browser extension, which was actually what was beaconing back out and then installing of various other items, was consistently reoccurring because of the fact that it was existing within Chrome. The other reason is that Chrome extensions inherently are very difficult to detect from actual EDR-centric tools because most of those tend to be process-centric tools. So you're seeing the process of Chrome, which is obviously a legitimate process, but within that process, you're seeing the browser extension running, and that's actually what's causing the problem, making it very difficult to discern because you can see the extension within a registry key or loaded within a file mod, but it's hard to distinguish what's legitimate and what isn't because you're not actually seeing it from a runtime capacity. So with all that said, real-world use case, because I was able to install OS Query, figure it out in a matter of seconds, and then move on with our lives. So that whole process of the IR, which they were looking at for several months, took 5 minutes, and that was with OS Query, not with AI Query. Helped me write the query. So with that real life use case, here's what we got. So we have browser extensions, again, kind of just breaking down how adversaries can try and hide these and can be in an already compromised system. Just helpful for the breakdown of the actual technique, some examples in which this is utilized, mitigations, and detection as usual. But now that we've set the stage, let's hop on into the tech and actually show you how it can be done. Okay, so pivoting over here to our AI query console, we actually have an out-of-the-box query for Chrome extensions. If we want to see that, we can say Chrome, and there we go, out of the box, and pretty sweet. But again, this is AI query after all. Might as well show you how the sausage is made and actually utilize AI and QuerySmith to write the query for us. So we'll hit Use AI, open up QuerySmith, and we're going to want to select the attack mode, so specifically the TID, so exactly what we're looking at within MITRE. What we'll do is we'll just copy and paste in that TID. If I can double click, perfect. And we'll do that, and then we'll do hyphen Chrome extensions and hit generate. So the reason we had to specify the Chrome extension piece is because that actual TID, if you saw it there, is about browser extensions. So that could include Safari, Firefox, etc. And there are different tables for each of those. So in this case, just want to focus on Chrome extensions because that's what I set up for the demo environment. But also that was the real life use case that incited all of this in the first place. So we can see we have our extensions query right here, which is great. It's got the identifier, the name, the version path, and the update URL from extensions. So while that's all well and good, what we need to do is we need to attribute users to this because that's actually how it's going to do. It's going to pull the user's profile for the applicable Chrome extensions. So that's where we'll utilize refine and say join users table as primary table, include username, and hit refine. So again, this is kind of where I like to think of the builder and the generate as the general context, and then use refine to kind of hone in on exactly what you're looking for. And as you can see very simply there, it's now changed from users, join Chrome extensions on users UID, where it's the common field of Chrome extensions UID, and we can see it added users.username. That quick and simple. So looks perfect. We'll go on ahead, we'll hit accept. And this particular device that we have selected, it's not that there's anything wrong or anything with them. It's more just that they have access to sensitive data. So we're more moderating it from a GRC standpoint to make sure that they don't have anything that has too strict permissions or too loose permissions from an extension that could be potentially problematic and maybe share PII, what have you. So we'll execute and then we'll pivot on over, check out results. We'll hit refresh right here and we'll give it just a moment. We can see it is currently in progress. And there we have a result. So we'll open it up and we can see here we have a couple different ones. So we have Google Docs Offline, Grammarly, Loom, Chrome, and Google Docs and Edge relevant text changes. We can see the username for all of them is Nick, which makes sense as he's the primary user on that device. So next, what we can do, we now have the critical information. What are the Chrome extensions that are being auto-loaded into the actual device at the time? You can check for persistence. That's another field that we just didn't have included here because right now, the main thing we're looking for is getting these extension IDs to do further research. Now, I used to utilize this tool called CR Excavator as a super awesome open source tool, but it looks like it's recently been shut down and kind of hasn't been updated and not utilized. But as a result of that, diving down Reddit threads, found another cool tool. So we'll check out Grammarly right here and check out CR Explorer, which I already had a search up there for Loom. But in this one, we'll hit right here. We can put in the Chrome extension ID and then hit search. And we can see, oh, hey, it's already got a result for it, which is excellent. And we can see Grammarly right here, got 48 million users. That's awesome. Love it when people's grammar's better. And then we can see the total ratings, and that is generally safe because it's a reputable company. So that's like a quick and easy one. However, the extension permissions are broad, but they largely align with the functionality, which makes sense, right? Because you see it's only a medium risk, right? Only medium risk. We can see the web resources. It gives a nice little breakdown if you hover over, where it's HTTP ***, HTTPS ***, and kind of in a bunch of these. Because if you think about what Grammarly is doing here, right? It's an AI-assisted grammar tool. It's going to go ahead and make changes and kind of help you with your proper grammar while writing, which also requires a lot of access. So if we're worried about this individual user and their access to sensitive information and potential PII being leaked through these checks, then maybe even though we know this isn't a malicious extension, we may not want to allow it for this specific user's device or put additional constraints around it. Either way, just helpful to be aware of the actual required and associated permissions of exactly what it's doing. So now that we have that, there's additional things you could look at, the actual manifest, the code itself, which is pretty freaking awesome. But again, CR Explorer, I'll put it in the description. Super useful, super cool tool. I know there's a bunch of other ones like Secure Annex that are also awesome. Just happened to stumble on this one and wanted to mention it. But we now know that, okay, Grammarly's legit. We know it's legit, but we don't want it on that user's machine because they're access to sensitive information. So what are we going to do from here? Well, of course, we're going to go ahead and take action on that. So let's go on ahead and we'll open up Live Shell here on another tab just so we can reference back the Chrome extensions, select the device in question, and hit continue. All right, and here we are remoted into that target device via Live Shell. Again, wildly powerful tool, direct access to the machine through our agent for remote remediation based on the verbose data gathered, which is exactly what we're going to show right now. So let's use our AI assistance so that I don't have to memorize every command that exists. And what we're going to want to do is pivot back on over to the tab we kept open here with our query results. And let's copy out this extension ID that we just looked at, saying, hey, unfortunately, we're going to have to remove Grammarly from that device. We don't want that level of permissions or access to our sensitive information. So let's say remove Chrome extension for user Nick with the ID of boom, copy, paste, and hit enter. So let's see what AI drums up for us. As a reference point, I actually had to redo this video because I realized my head was in the way of this. But here's the device that I'm remoted into. And as you can see right here, we have our little Grammarly and our Loom Chrome extensions pinned right there. And perfect, right here, remove item path. And it's going to specify the path to the extension, which is critical. That's what we need to know. And then we can say recurse force. Perfect. So we'll Control V and hit enter. And so doesn't look like anything happened, but let's pivot back on over and let's go ahead and try and click on that real quick. And oh, boom, it's gone. And like it's gone. And that is because, again, it is deleted. So this recurse, so it actually deleted everything within the data directory, but I believe there are still registry key pieces. Like you want to actually properly uninstall a Chrome extension ideally. But in the scenario where maybe it's beaconing out, right? Maybe it's not just something that we're worried about from a GRC standpoint with too many permissions, but it's actually something we're worried about from an attacker standpoint. Well, doesn't matter if it's done properly or not, just destroy it, remove that item. then you can go through and remove all the other relics, but make sure that that initial persistence mechanism is not there, and then you can go through and persist and consistently kind of go through and whittle that down if there is anything left over, any additional remnants. But that's kind of the full scope. So able to identify a persistence mechanism hiding within a browser extension, a very common one for a lot of EDR-centric tools and NGAV tools to miss given the process-centric nature and how those are loaded. Also a difficult one because if you reimage a device and the actual Chrome extension is associated with the profile, it'll come right on back. But aiquery makes it wildly simple to actually gather the information, and then, as we showed, be able to cross-reference with a pretty cool tool like CR Explorer right here, get some additional details, and then ultimately use Live Shell to go ahead and take action. So hopefully that was a helpful video. Please check out our additional videos on our LinkedIn and our YouTube channel. If you have any suggestions, please let me know, and otherwise, thanks everyone. Till next time. See ya.